pi, we're going to start solving some trig equations. And it's just the same as solving any normal equation, but we now have to, once the trig portion is isolated, figure out what values of x would give us that trig ratio. So clearly here to solve this, we would just divide out, because this is 2 times sine of x, divide out the 2, and we would get sine of x is equal to 1/2. So that's the easy part. That's no big deal. But when is sine of x equal to 1/2? So if I sketch out a sine curve, and I'm going to do the best I can to make this nice and neat, let's see here. Let's see, this will be pi, 2 pi, 3 pi, 4 pi. This will take a few minutes. Okay, so when is sine of x equal to 1/2? Let's look at the sine curve. Let me use a different color. Let's see, so it's starting here, it's going up. Oh, that doesn't work. Try that again. I'm going to draw this as neatly as possible. Obviously, it's not going to be perfect. And you don't have to draw this curve every time. You can just use your unit circle. But I just want you to understand how many solutions there will be to this. So that's why I'm sketching this out for you. That's not pretty. Ugh. Okay, whatever. All right, so when is sine of x equal to 1/2? So we could actually plot this out. 1/2 is right here. And we can draw a horizontal line. And we can see that as this continues, there's an infinite number of solutions where the sine is equal to 1/2. Every time the graph crosses this, there's another solution. So how would we represent infinite solutions? We look at the solutions in the first period, which is this section from right here to right here, just that one iteration of this. And then we're just going to realize that the period of the sine function is 2 pi, and all we have to do is add or subtract 2 pi. So in this one section, let me sketch that out for you. In this one section, there is, let's look at this section, this first section of the sine function in that little box. You can see that there's 2 solutions in that box. So this solution, if we add 2 pi, is going to be that one. If we add 2 pi, is going to be that one. And if we subtract 2 pi, it's going to be that one. This solution, if we add 2 pi, will be this one. And if we add 2 pi, will be this one. And if we subtract 2 pi, will be this one. So since the period of the sine function is 2 pi, all we have to do is keep on adding and subtracting 2 pi. No big deal. So let's figure out what these 2 solutions are, and then we're going to add and subtract 2 pi. Well, let's see, back to red. This solution is pi over 6, and this solution is 5 pi over 6. Let me give you a hint. If this is pi, this is 1/6 this way, this is 1/6 that way. So you can kind of see that there's some symmetry here. Just as far as finding your values, if you find that one shouldn't be too hard to find. So this is 0 plus 1/6. This is 1 pi minus a 6, which is where we're getting 5 over 6. Anyhow, if you didn't get that, don't worry too much about that. All right, so this value is corresponding to the pi over 6. So this is pi over 6 plus 2 pi. And this one would be pi over 6 plus 4 pi. And this one right here would be pi over 6 minus 2 pi. These ones will correspond with the 5 pi over 6, so this would be 5 pi over 6 minus 2 pi. This one is 5 pi over 6 plus 2 pi, and this one is 5 pi over 6 plus 4 pi. Oops, running out of room. All right. So anyhow, the way that we can write those solutions in a little bit of a neater way is by using these ones, and we're going to add and subtract 2 pi. So we would say x is equal to pi over 6 plus 2 pi n, and 5 pi over 6 plus 2 pi n. Now in this case, n is an integer. So if n is 0, it's giving us these two values. When n is 1, it's going to give us these two values. When n is 2, it's going to give us these two values. And if n is negative 1, it would give us these two values. So as n, basically since n can be any number, it could represent any possible solution of this. So these are all of the possible solutions of this equation. So you find the original two, and then since the period of sine is 2 pi, we add and subtract 2 pi by representing it like this. You add 2 pi n, and n is any integer.